I'm going to lecture on writing Lewis dot structures of molecules. So unlike the other lectures, this lecture is not going to have a PowerPoint with it. Everything is going to be done using the whiteboard, which is pretty much what I do in class. I'm probably going to break it up into 2 or maybe 3 videos, depending on how long they get. I try to keep them 15 minutes or less. Anyway, Lewis dot structure is, and you've done this for atoms, but we haven't used it in a long time. This is a way of determining a structural formula of a molecule, which a structural formula, I think I showed you a long time ago, it's the arrangement of the atoms. So instead of SO2, well, where's the sulfur, where's the oxygen, who's attached to whom? So what's attached to what, what's in the middle, what's on the outside, are there single bonds, double bonds, triple bonds, are there unshared pairs of electrons, things like that. It doesn't get you the shape, but it's the first step. The very last thing we're going to do, which is right after this, is going to be molecular shape. Right? So it's the first step to shape. Now this is only for covalent compounds, molecular compounds, depending on nomenclature that you use. So remember, covalent compounds were sharing electrons. This is nonmetals. Nonmetals want their valences filled. So remember the octet rule. Everything wants 8 electrons in its valence. I do things in pairs of electrons, so that would be 4 pairs. Remember, however, that hydrogen is an exception. Hydrogen's valence is filled with 2 electrons, which means it'll only have 1 pair of electrons. This would be a good opportunity to review the periodic table and, excuse me, how to determine how many valence electrons something has. But remember very quickly, the valence electrons will be the same as the number in the ones place in the group number. So for example, oxygen, which is in group 16, there's a 6 in the ones place, we'll have 6 valence electrons. Or you can go through all the 1s2, 2s2, the electron configuration. The way I'm going to do this, over here, these are the steps to writing Lewis dot structures. I put them in the canvas shell, right before this whiteboard. And these are the steps. And I'm just going to do a bunch of examples, and I'll just leave these steps up here. And these steps aren't going to make a lot of sense until I do the examples, but let's just go with it. So the first step is determine the total number of valence electrons. Then we're going to divide by 2 to get pairs of electrons. So the book does this with dots. I do it with lines. A line is the same as 2 dots, right? So just remember 2 pairs of electrons. A pair of electrons is 2 electrons. Then we're going to guess the central atom. So some things to make it a good guess. It'll never be hydrogen, because if hydrogen was in the middle, if you're in the middle, that means you're attached to at least 2 things. Each attachment is a bond is 2 electrons. If hydrogen was attached to 2 things, it would have 4. And remember, hydrogen only gets 2 in its valence. It's usually the thing with the least number of valence electrons. It's usually the least numerous, usually the least electronegative, but these are usuallys, all right? Then we attach all the atoms to the central atom with single bonds, and at the end of this stage, all the atoms should be in the structure. Then we determine the remaining pairs of electrons. I call it rem for remaining. Remaining will be your total pairs from step 1 minus the number of bonds you drew, okay? Then what do we do with those remaining? If there are no remaining pairs, we skip step 5. Then we put the remaining pairs of electrons in the structure. We fill from the outside in. So we put them as unshared pairs on the outside atoms until the valences are full, so that you have to keep track. Remember, bottom line, you'll never have more than 4 lines touching something. All right? And then once the valences are filled, on the outside atoms, if you still have electrons, you go to the central. After this stage, all the atoms and electrons should be in the structure. So think of if you've ever built something from, say, IKEA, you don't want any extra parts. Then we check the valences. And like I said, everything should have 4 lines touching it. And if we're done, we're done. If not, if there's a deficiency, it'll likely be that central atom. Then what we do is we convert an unshared pair on an outside atom into a bond to the deficient atom. Right? And then we check for resonance. And like I said, I'm going to go through a bunch of examples. This will make way more sense as I go. So I'm going to kind of move this over here. I think that's big enough that you can read it. You guys have young eyes. So let me just go through some examples. And I'll just do a couple, then I'll stop the video. And remember, each time I do this, you can stop the video. It just wouldn't work on a PowerPoint. You can stop the video and have a look at it. You can stop it at any stage. And I highly recommend taking advantage of that opportunity. Let me just make this font. Well, we'll just leave it like this. All right, so let's do We'll start with a simple one. Let's start with methane. Okay, CH4. I'll try to make my handwriting better. So the first step, we have a carbon and we have hydrogen. All right, we have one carbon, we have 4 hydrogens. Carbon, if you remember, look at the periodic table, has 4 electrons in its valence. Hydrogen has 1 electron in its valence. That means there's 4 and 4. That means there's 8 electrons. Divide that by 2. That means there's 4 pairs. That's step 1. Now, the next step is we're going to go to the central atom. If you guess the central atom, and it's not hydrogen, so carbon is the central atom. Then we're going to attach all the hydrogens, step 3, to the carbon. So we're going to, here's the carbon. We're going to attach the 4 hydrogens. All right, now we go to step 4. We determine the remaining pairs. Well, I originally had 4 pairs from up here. I have used 4 bonds, 1, 2, 3, 4. So I have no remaining pairs. That means I can skip step 5. Now we'll go to step 6. We check the valences. So each hydrogen should have 1 line touching it, 1, 1, 1, 1. And the carbon should have 4 lines touching it, 1, 2, 3, 4. That means we are done. This is the Lewis dot structure of methane. All right? Let me see if I can stretch this just a little bit and see if we can maybe squeeze a second one in on each page. Let me just erase a little bit. I'll erase this part right here. All right? All right, let's do another one. So these aren't, if this is another one of those things, I try to give you all semester, I try to give you step by step. It's very important that you follow the steps. I've seen some very, shall we say, creative Lewis dot structures in my career. And if you follow the steps, I didn't come up with these steps, but they're very good. All right, so let's do ammonia. Ammonia is NH3. So same approach. And if you want, hit pause and try this on your own. There's N, there's H. There's 1 nitrogen and 3 hydrogens from the formula. Nitrogen has 5 electrons. Hydrogen has 1 electron. That means 5. That means 3. 8 over 2 is 4 pairs. All right, once again, the nitrogen will be the central atom here. I'm just going to attach the hydrogens. All right, so now for my remaining pairs, I had 4. I've used 1, 2, 3. That means I've got a pair of electrons that I've got to put in the structure. Now, where do I put it? It says to go to the outside atoms. If you look over here, if I make it a little bigger, I could do it like that, couldn't I? It says to put the remaining pairs in the structure as unshared pairs on the outside first until the valences are filled. But in this case, the outside atoms are hydrogen, the valences are filled. So then we're going to put the unshared pair on the nitrogen. I'm going to draw it down here so you can kind of see what I've done. So I'm just going to redraw it. So now I'm going to put this bond, or this pair of electrons, as a pair of electrons just there. It's not shared. It's an unshared pair. It's a pair of electrons that's not shared. All right, now we're going to check everything's in the structure. Now we're going to check the valences. Each hydrogen has 1 line touching it, 1, 1, 1. And the nitrogen has 1, 2, 3, 4. Now, just to remind you, this, and of course they're barking, this is an unshared pair. And this and the other ones are bonds, shared. Unshared pairs are very important to the chemistry of this molecule and how that plays out. You'll see when we talk about shape where that comes into play. But just in terms of the chemistry, when you guys go on to organic chemistry, it's going to be very, very important to all that stuff. So it's very important that you draw unshared pairs. All right, let's go ahead and try another one. Let me do one more, and then we'll stop the video for a minute just see if I can leave these things up here for a little bit until they get more complicated. Let's see if I can play around with this thing. I got an idea. Let's make this a little bit bigger, and we can move this over here now, so you can kind of see what I've got. All right, let's go to, yeah, that's a good way to do it. Clever, Rob. Not as dumb as I look, huh? I'll just move things around like this. It didn't work. All right, let's try water. All right, and again, you guys can try these on your own. So this would be water. So we have hydrogen and we have oxygen. We have 1 electron and we have 6 electrons. There's 2 hydrogens. There's 1 oxygen. So 2, 6. Once again, the next ones won't have, only 4. All right, so then we say, okay, oxygen's going to be the central atom. Draw it like that for now. Then my remaining pairs, I had 4. I've used 2. I have 2 pairs. Those 2 pairs can't go on the hydrogens. Remember, thou shalt not attach more than 1 line to hydrogen. So we go H, O, H, and we'll put them in here. Okay. Now we check the valences. Step 6, 1, 1 for the hydrogens, 1, 2, 3, 4 for the oxygen. So that's the Lewis dot structure of water. Now water is not linear like this. It's bent. We'll talk about that in the next little unit. All right, I'm going to stop the video here just because I want to keep them not too long, and I'll start the next one, pick up here.